simple answer is that Ethernet is like that because it has to be. But if we want to go a little more in depth, we should get to the question just below the one in the title. What even is Ethernet like? Ethernet is not a cable. It is not the RJ45 connectors that connect those cables between computers. In fact, Ethernet is a media agnostic technology. That means it can run over anything. It could run over coax, it could run over RJ45 Cat6, it could run over telephone cables, it could even run over wireless if you really wanted it to. Though, most people don't, instead using something slightly better suited to that specific media. So if we know what Ethernet isn't, what is Ethernet? Ethernet is a layer 2 networking technology that packages data into packets called frames and sends them between hardware addresses over a bus-style network. But what does that mean? Let's go into a basic rundown of how all that works. We start off with some data that is split up into smaller pieces and handled by some higher layers of the OSI networking model. Then, that data is given to Ethernet, which puts it in an Ethernet frame. An Ethernet frame is kind of like an envelope for your data. It has a header that lists a little bit of information, like length of the data and what's in it, and addresses, to and from. These are what are called MAC addresses, Media Access Control. Unlike an IP address, a MAC address is, one, tied to your hardware. So your network interface card, for example, has a MAC address built into it. And it does not change. So every computer on an Ethernet network has one MAC address that is constant. And if it moves to another network, it has the same address. And finally, that information is sent out over a bus-style network, though it can be sent over a star network sometimes. Of all of that information, the least explained part was probably the network types. What is a bus-style network, and how is it different from a star network? There are generally 4 types of network: bus, star, ring, and mesh. In a bus network, every host will send and receive data over one shared line. In a star network, every host sends data to a single central point which handles switching and routing to get that data to where it needs to go. In a ring-style network, data is passed along between each machine, and every machine connects to 2 other hosts, meaning there are 2 wires in a physical implementation of a ring network. And in a mesh network, every machine connects to every other machine, so all hosts talk to all hosts. Okay, so now we know what like that means, but we still don't know why it's like that. Why is Ethernet a system with addresses, frames, and all of it running over a bus-style network? The first 2 things, the addressing system and the frame system, are pretty standard stuff for a networking standard to have, but the bus network is an odd choice. Why would you go with a bus network when they have so many problems? Well, looking at the differences between a bus and a star network, a bus network will have collisions, they'll have usage-limited bandwidth, and they'll only ever be able to send and receive at half duplex. Where star networks have no collisions, no bandwidth ties to usage, and all data can be sent and received at full duplex, meaning you can go both ways at the same time. So, why is Ethernet usage limited? On a simple level, if everyone is talking, you won't be able to talk either. Machines on a bus network have to wait their turn. If all three of these other machines are talking, then the line will be busy, and machine D won't be able to use the network at all. The more users you have, the slower your network becomes. So, now that we know why a bus network is usage limited, the next question is, why is it only half duplex? Well, if we take a look at this diagram, we'll see that there's only one shared line. Up close, that would look like this. A bunch of little wires with what's called a vampire cable connecting machine D into the shared line. And this means that we only have one wire for out and in. If we wanted to go full duplex with something like this, we would need to basically turn this bus network into a mesh network, which would make it expensive, complicated, and impractical to use. Okay, so we know why it's limited to half duplex. What about collisions? In fact, what even is a collision? Essentially, a network collision is when two hosts try to talk at the same time. Both of them send their data over the shared line, and the two packets meet and mangle each other, interfering, destroying any information. So no one gets their message. Network collisions are really bad, and they're about the worst thing about a bus network. And the more devices you have, the more collisions you're going to have. Alright, so we know what the problems are with being a bus network. What does Ethernet do to solve it? Well, there's its best feature. The greatest innovation of Ethernet is collision avoidance. On a bus network where everyone is talking over the same media, you need a system to make sure that people don't talk over each other. It starts with step 1. Listen. Don't attempt to send until you're sure the network is quiet. Then send, if the network is quiet. If a collision occurs, if two devices talk at the same time, there's a couple more steps. First off, each device picks a random number and waits that long before trying to send again. Ideally, one of them gets a number that takes longer than the other, messages get sent, and everything goes back to normal. But if there is another collision, they will pick a larger random number and wait that long. This will continue until someone sends a message successfully, resetting the network to 0. If data arrives, the machines will exit collision avoidance mode and go back to the standard Ethernet protocol of waiting and only sending when the bus is quiet. Okay, so we know that Ethernet solves the problem of collisions, but it doesn't solve the other problems of a bus-style network, those being the half-duplex rates and the usage-limited bandwidth. So why even be a bus network in the first place? There are a couple reasons why it's a bus instead of a star network. The first reason is that it needs to be media agnostic. Remember, Ethernet has to go over anything. It has to go over coax, it has to go over telephone, it has to go over the air. all of those are Ether. The same thing to the protocol. So some can support stars, like coaxial cables, but some don't, like the wireless. So if you need to send over all of them, you can't send as a star network. It has to be a bus. And the second reason is pretty simple. Ethernet is really old. Back in 1980, when the standard was first established, computers were expensive, they were limited, and frankly, they were too important to waste on a job like packet switching. A mini computer of that time would still cost thousands, 1000s of dollars. Even today, a good network switch from Cisco is going to cost you a lot. And these computers could be doing more important work. Spending all that money on a computer to switch packets over your network wasn't worth doing back in 1980. So, that's why Ethernet is like that, even though a bus network had so many shortcomings. Ethernet had its very specific features chosen to be flexible, to be simple, and to be inexpensive. And those three things, those three features of Ethernet, are why it won. And it did win. You see, it wasn't always like today where Ethernet's the only networking standard people use. It had competition. Things like IBM's Token Ring standard. That was a ring network. ArcNet, FDDI, lots of other competitors were going for the same system, but Ethernet beat them all, even when it wasn't that fast. FDDI was faster than Ethernet until Ethernet got an upgrade with fast Ethernet at 10 megabits per second, and later modern gigabit Ethernet with 10 gigabits per second. These things about being expandable were something the other systems didn't have as well. You can't use a token ring network anywhere, but you can use Ethernet anywhere. Well, I hope you liked the video. Now go watch someone else's video, or another one of my videos, or go outside. This video will be over in 12 seconds, no matter what you end up doing afterwards anyways.